Number 17 in your classwork for properties of parallelograms, we want to decide if the figure is a parallelogram. So here we're going to recognize that we have already one pair of congruent sides. So this pair that are opposite of each other both have a measure of 6, so they're congruent. Now the only thing that's missing is to prove that this pair of sides are congruent, and we would get a parallelogram. So in order to do that, we're going to drop a perpendicular line from one of the vertexes, and the same from this vertex here. So when we do this, we know that we form a right angle here, and a right angle here, and we have a right angle here, another one here, and basically when we have this set of parallel lines going in between them, we know that they're going to be of the same width, so let's call that width D. And we also notice that we form a right triangle here, and over on the other side as well. So using the hypotenuse-leg theorem, since these parallel lines are spaced apart by some distance, let's call it y, using the hypotenuse-leg theorem, we know that this triangle, if that has a base leg of x, then this triangle is also going to have a base leg of x, because it has the same side measure, hypotenuse measure, and it is a right triangle, just as the other one. So if this side of the parallelogram has a measure of d plus x, and this side of the parallelogram has a measure of x plus d, then those two sides are congruent, meaning that we have a parallelogram. So our theorem that we use is that opposite sides are congruent.